Hey, Matt Mathersum here with Matt Mathersum. Thank you so much for joining us and being a part of the program today. We really do appreciate it. Well, today we are going to be continuing our discussion on the chain rule. Last week we talked about the chain rule and how we could use substitution to work some problems out. I think we even figured out the dy dx, how that formula came to existence. Well, today we're going to be, like I said, continuing with the chain rule. And why? Well, we still have a composite function, just like we did last week. Although this time we've got a radical, so I'm not the only radical here. And we've got this inside, or underneath, I should say, the radical. That's why this is a composite function. Dealing with composite functions, again, makes us use the chain rule. So when you look at this, what automatically pops into your head about how to use this chain rule? First thing we want to do is get rid of the radical. You're not getting rid of me, but we can get rid of this one. So let's go ahead and figure out how to do that. Well, we understand all the time there's an implied 1 here and there's implied 2 over here. That's really the secret to getting rid of the radical initially. So let's just go ahead and do that. And now we're left with just 2x3 minus 1. All right, but we have to put our fractional exponent here, don't we? Well, we do. Okay, that's how this whole chain rule thing is going to work. This is our inner part, our inner function, and this is our outer, right? So let's go ahead and say dy with respect to dx, because we know that's where this is headed. We got to bring our 1/2 down in front. Chain rule, right? Real simple. We're not going to flip out here. So we've got the 1/2 out in front, and I'm just going to rewrite our inner function again, right? No big whoop here. But I do have to subtract the 1/2 from 1, right? I do have to decrease this. This is the chain rule. So 1/2 minus 1 gives us what? Yeah, it gives us a negative 1/2. Okay, well, not too bad. So far, so good, right? Well, let's see. What happens if I deal with this over here in the parentheses first? Well, I know my negative 1 is a constant, so I know that goes bye-bye, sayonara. That's a 0. Well, what about this x to the third? Well, we know that with the power rule here, just take the 3, and I'm going to multiply that by the 2x, and I'm going to end up with 6x here, aren't I? 6x squared, actually, because I have to decrease. Decrease? Well, we can decrease or depress this, but actually I have to lower that by 1. Either way, we do that. Okay, so now we're left with 6x squared times 1/2. Well, what's 6 times 1/2? Yeah, that gives us a 3, doesn't it? So now we are left with a 3x squared, aren't we? All right, moving right along. Okay, well, what's left now? Well, I can see that I'd like to get rid of this 2x to the third minus 1 to the minus 1/2 for obvious reasons, because it's a complete mess and we just don't need it. This is our inner function, and we can do something with this so that it's not so hideous. So all I've done is just rewritten this, but what's going to happen is I'm going to put this as our new denominator, okay? So here's how this is going to work. I'm going to erase this right here, this part right here. All right. And what I will do, I'm going to bring this all down, eliminating this negative fractional exponent. We will put it back under our radical, say hello to the radicals again. And now we have 2x to the third minus 1, but no negative, nasty looking fractional exponents. And this, my friends, or ladies and germs if we prefer, is the answer 3x squared over 2x third minus 1 square rooted. Okay, well, that's all the time we have for here on Math Madness. I am Matt Mathersum. Thank you so much for joining me today. I'll see you anon.